Hello, and welcome to SaaS Tenant Isolation Patterns. My name's Todd Golding, and I'm a Partner Solutions Architect at AWS, and I'm part of what's called the SaaS Factory team. And that team works with organizations that are in various stages of adopting SaaS on AWS. They're building, optimizing, they're in some path to delivering a SaaS solution on AWS. And one of the core principles we work with these organizations on is this notion of tenant isolation. And tenant isolation is this foundational concept. So what do I mean when I say tenant isolation? Well, imagine building a multi-tenant architecture on AWS. And in that model, when you're trying to build a multi-tenant SaaS solution, you're essentially saying, I'm going to take the resources of my solution, the compute, the storage, all those infrastructure concepts, and I'm going to try to pour them into some unified experience. And wherever I can, I'm going to try to share resources. I'm going to try to share compute. I'm going to try to share storage, all because I can get this better economies of scale, I get a better management footprint, and I get all this sort of agility and an ability to sort of align tenant consumption with the actual infrastructure costs of my system. And that's very appealing to organizations that are moving to SaaS. Of course, when we move into this model and we begin to share resources, we also get into a mode where we have to think about what do we do to protect one tenant from another tenant. Essentially, we have to worry about scenarios where a tenant may be able to try to access the resources of another tenant. This may be entirely unintentional, but you can imagine the impact that could have on your business. If a tenant somehow is able to reach across from its context into the resources of another tenant and see their data or see some of their resources, that would be a huge setback for your business. And so what we have to do here as architects, multi-tenant SaaS architects, is think about what can we do to put a context around these individual tenants? What can we do to make sure that they run in this isolation context that ensures that our business will never have a scenario where one tenant somehow inadvertently gets to the resources of another tenant. And it's really important here. Some people, when I talk to them about this, they'll say, well, we don't really think this will happen, or this is a really rare scenario for me. And I would acknowledge that this may be really rare. But even in the one instance where this may happen, it will be a huge impact to your business. It'll be a huge impact to your customers. And so you want to take every measure you can, and you would be hyper-focused on isolating those tenants and being sure that you're protecting for this one time where something may cross a tenant boundary. So then what does it mean to build in a multi-tenant context? What does it mean to architect in a multi-tenant context? Well, what we're going to do here is look at the patterns and the strategies that you use to implement multi-tenancy. And the reality is the storage we're using, the compute we're using, the multi-tenant architecture we have, all of those require different isolation strategies. And so we're going to have to look at and break this apart into pieces and look at patterns and approaches that will define how you can approach multi-tenancy in your own solution. And we won't cover this comprehensively. We won't cover every sort of angle. But what we will do is sort of dig into some of these common themes, and then you can extract from those themes the bits that will be good for your particular solution. Now, I was at a reInvent session a couple years ago, and I was in a chalk talk, and I was sitting with a bunch of developers, and we were having this discussion about isolation. And in that discussion, I was asking, there were the team and the groups in the room, like, what is your approach to isolation? How are you covering that today? And I sort of got varied response to that. And I finally asked, how many of you are just using authentication as your approach to isolation? And about 75% of the room raised their hand. So in that case, these developers were essentially saying, I'm going to authenticate you at the front door. I might use some notion of authorization, and that authorization will control your access to the APIs or the entry points into my application. And I'll even challenge you as you try to access other resources with authorization. And that will be my entire story for isolation. Now, while I acknowledge that that is a really good approach to sort of securing your system, I would also say that isn't everything you need to get to a complete isolation model. So if we look at isolation, we add more layers onto this authentication and authorization story. So if we look at the example on the right here, you'll see we have an application service. Yes, we've been authorized, we've been authenticated, we're into that application service. But now within that application service, we're not going to trust that just because you've been authenticated and authorized that you are okay to do whatever you want within the scope of the system. Because we're still running code in there, and that code could still do something unintended to cross a tenant boundary. So this is where we add the extra layer of isolation here, right? We're going to use some mechanism. I've just shown a policy here. We'll see that there's multiple approaches to doing this. But essentially, I'm going to say, once you're in here, even though I know who you are and I know that you're authorized, I'm going to surround your interaction with other resources with these policies that will enforce our isolation policies and ensure that as you cross a boundary to go access another resource, that I lock it down to just those things you're allowed to see. And to me, that's different than just authentication and authorization. It is that extra layer that gives us the confidence that our isolation scheme is going to prevent unintended or intended crossing of tenant boundaries. Now, I really want to also talk about what approaches might influence the strategy you pick. What things might drive your isolation strategy? And there's a variety of things that might drive that. Tiering strategy. So imagine in your solution, you have a basic and advanced and a professional version of your solution. Well, it could be that these different tiers of your system might actually have different approaches to isolation. Now, they're all going to support isolation, but they're just going to support it in different models potentially. So at the basic level, I might say this is a fully shared infrastructure environment. It's going to still have full isolation, but you're going to run side by side with other tenants in the infrastructure. And maybe at the professional level, I'm going to say, no, at this level, I'm actually going to give you your own environment. I'm going to let you have a fully isolated environment because you're willing to sort of pay for the premium of that. And so if that's what my customers want, and if that's what my business wants, that's going to be my approach to tiering here. And that's going to affect the way I sort of architect the isolation strategy of my solution. Another influencer here, it's slightly different. This is less about a security profile and maybe more about performance and the experience of your tenant. Some tenants may just say, I don't want to live alongside other tenants because I'm worried about the notion of noisy neighbor. I don't want my performance and my experience to be impacted by the performance of other tenants in the system. So carve me out an isolation view into the system that isolates me and lets me have my own access to resources that won't be impacted by other tenants. Now, compliance is really probably the most common theme we'll see here as a strategy. If you're in a highly regulated business, healthcare, financial services, or one of these spaces that has all these regulations attached to what it means to operate a SaaS business, now you have to figure out how those regulations might influence your isolation strategy. And so you'll find yourself doing very specific things in your isolation to cover those compliance needs. Now this middle slide, and I always sort of laugh when I see the icon here for this one, sort of a very dated icon, and it's kind of a goofy looking icon, but it sort of conveys this notion of legacy here, which is to say we have this really old architecture potentially, or maybe it's not even old, but it's not modern and it's something we're migrating from. And because we're migrating from that environment, we're going to have to factor in how that can come forward with us and how that can come forward with us and still let us achieve isolation. So the constructs we have that we're starting with may affect the shape and the structure of the isolation that we end up with. And the last one I always have to include this is this notion of opportunity. And the idea here is no matter what isolation scheme you implement, if somebody comes to you and a potential customer comes to you and says, we really have this very specific isolation demand of your system, we really want to do it, and we're willing to write you a really big check for it, we're probably going to use that and shape that and bring that into our strategy somehow. Now, there are multiple flavors of isolation, and there are a couple of core themes that we really want to focus on here. You'll see me use this word silo and this approach of siloing resources, and we'll use it in multiple contexts here. But the basic idea of a silo is to say some resource is fully isolated from another resource. The tenants aren't sharing that resource in any way. And certainly this is one form of isolation, and it's the easiest one for everybody to sort of implement and understand, which is to say we're going to give every tenant their own full stack, we're going to give them their own set of resources, and then we're just going to use the natural constructs that come to us inside the AWS stack to isolate these resources. Networking constructs, VPCs, accounts, all these other bits to separate them. And those constructs give us really concrete and simple ways to describe our isolation and make it a lot simpler to implement. On the other side of this, though, is the real goal we often have with SaaS, which is we say, no, we want to share these resources. And when we share them, we call that a pool model. And in a pool model, we're saying, no, we're going to take all these tenants, we're going to pour them into a unified environment. The services, the capabilities in the environment will be shared. And now, because we've poured them into this shared experience, we have to ask ourselves, well, now, what is the isolation story in here? We can't use these sort of more coarse-grained constructs that we could on the silo side. We have to find more fine-grained mechanisms. We have to find a way with policies and other approaches to define how we will isolate resources here. Now, both of these are perfectly valid, and we'll certainly look at the nuances of these. And again, silo could be for just a portion of your stack, not for all of it. Another dimension of this we want to think about is the target markets and the target segments we're going after. I was working with one particular customer, and they'd come from this very traditional enterprise environment, and they'd sold to these customers that had a very specific profile for compliance and security, and a lot of selling to those customers was convincing them that they met all of these high compliance bars. And they were more like the sort of profile I've identified on the left-hand side here. So that was a huge part of the motion for selling to these customers. But they were building this brand new SaaS solution. And so I said to them, so what's the isolation strategy? What's the approach of your new solution? When they said, well, we're just bringing forward all the bits that we did with our traditional enterprise customers. And I said, well, are those the same requirements for your new customer and for your new segment? And we said, well, we assume if we had to do it for the big customers, we're going to have to do it for the small ones. And this is something I like to challenge, which is to say, as you're thinking about isolation, you should really challenge yourself to ask yourself, what are all the segments we have? So on the right-hand side here, for example, I have a tenant who certainly cares about isolation. Every SaaS tenant's going to care about isolation, but for them, they're more about the cost of the solution and the efficiency and the speed with which they're going to get functionality. And they're willing just to accept that, yes, it's in a potentially a pooled environment, but I trust that the isolation works. Well, if that's a customer you're going to target, you have to factor that into your overall isolation strategy. And so what I ask organizations to do as part of building their isolation strategy is step back, look at all the personas and the different profiles of customers you might need to target, and build isolation strategies that address the broader spectrum. And you may only end up in one bucket, but you may end up with multiple buckets, and you may have to find a creative way to address that. Okay, so what are some of the fundamental sort of isolation strategies? And we want to start with silo. We're going to, like I said, silo is a term I'm using here, and I want to start with silo as full stack silo. What are the AWS mechanisms I would use to implement a full stack silo isolation model? And I'll start with the simplest of these. AWS accounts is a very natural thing that people will like to use, and they'll say, essentially, I'll give every tenant in my system a separate AWS account, and I'll really rely on the security and the isolation supported by AWS accounts to guarantee that there's no cross-tenant capabilities. And you can imagine this is a very compelling scenario in terms of describing isolation to potential customers, but it also has some challenges with it. Provisioning in here is hard, setting up account limits for each of these new accounts, and even the number of tenants you may have to support may exceed the capabilities of having a separate account here for tenants. So you have to think about that, and obviously management and all the sort of decentralization of this can get more challenging as well. Still, a perfectly valid approach to doing a decentralized approach and a siloed approach to architecture. Now, what I see much more frequently, though, is this use of VPCs. So I'll see an organization say, no, we're going to put all the tenants into a common account, but we're actually going to have a VPC for each customer. So here, we'll use the natural sort of networking constructs that are available to us in a VPC, and we'll use security groups, and we'll use all these mechanisms to control ingress and egress to be sure that a tenant doesn't somehow cross a boundary they're not supposed to here. And then maybe we'll see organizations use VPC peering or other mechanisms to control access to these VPCs. The last one, and I'm most hesitant to include it, but I do see a little bit of it, is this notion of subnet per tenant. And here we're basically drilling deeper into the VPC and saying each subnet within the VPC will be a separate tenant. There's scaling challenges of this, management challenges of this, but it does show up once in a while. It's just really whether is there some compelling aspect of being in a subnet per tenant that is useful to your organization. But again, VPC per tenant is probably the most common pattern we see. So one thing I really want to emphasize, though, here that's super important is as we go to these silo-based models, we are still bringing with us all the experience of a multi-tenanted SaaS environment. So yes, every tenant will have their own stack, but we are going to surround that stack with a unified management, monitoring, development, deployment experience, right? We're going to basically have this level of services both at the top, that you'll see here, and on the right-hand side that are common to every deployed tenant stack. So, and each one of those stacks that are here will be running the same version, will be deployed by the same mechanism. So if you look at the top here, you'll see I've got common deployment. I've got a management plane that lets me see all the tenants through one pane of glass and see what's going on. I have identity that's common to all of this experience. And then on the right hand, you'll see things like metering and logging and metrics and all those bits that are also all unified across all of the tenants. So the idea here is, yes, even though each tenant is running in their own infrastructure, they're still being collectively managed, they're being collectively monitored, and we're gathering data from them in a unified way. And that really is what makes this approach a SaaS model. If we didn't put all these surrounding bits around it, this would probably lean more towards a managed services model, right? In a managed services model, we're saying, yes, we'll deploy a separate stack per tenant, we'll manage it separately, we'll monitor it separately, we'll even probably let customers have their own version. Where this transitions into being SaaS is when we have each of these stacks being managed by a unified experience. Now, pool-based isolation adds a whole new wrinkle to this story, right? If we look at what it means to be in a pool-based model where we're going to share the resources, and now these tenants are coming in and these tenants are sharing services and storage and all these other bits, we don't have these sort of coarse-grained mechanisms to define the boundaries between our resources. So we have to get much more creative about building an isolation story here. So if we look at what this really looks like, in fact, if we looked at one of these services running in this multi-tenant context and we were to sort of look under the covers at some point, we'd actually see that there may be all three of these tenants all running in a single sort of compute construct all at the same time. And we may see that we're all running against some notion of shared storage. Here I've got a table where each row in the table, each item in the table has a separate tenant ID. And then the question then becomes, so what's our unit of isolation here? If they're all in this construct, there's no sort of natural mechanism that is just going to put hard boundaries between these tenants in this environment. We have to get much more creative here, and we'll look at what we have to do in this pool-based model to really achieve isolation in that kind of setting. But the one thing we really want to be sure about here is that we can't rely on well-behaved code here. I will go to organizations that are building SaaS solutions and I'll describe the need for isolation in their services. And they'll say, well, our developers control that whole experience. There's no way anybody from the outside could get in and break anything. And we trust that our developers will do the right thing. And I generally think that developers are going to try to do the right thing. But I will also say that even when developers are trying to do the right thing, there are scenarios where a developer could do something that enables cross-tenant access, even though they didn't intend to. So I don't want to really rely on the sort of compliance of developers and the best practices of developers as part of my isolation strategy. I, in fact, want to take the developer out of that equation and introduce my own constructs that ensure that we don't break the rules of isolation. So if we think about introducing this idea of sort of policies at runtime and this way of attacking sort of a policy-based approach to this, let's look at what that looks like at a very high level conceptually. So I've had a tenant coming in, they've authorized, they've authenticated, they're in, I have a tenant context for them, they hit the API, and we will have isolation policies at that level that will say, can you get in? Now we'll have a little more discussion of API gateway and how that's applied here, and you could debate that this is just regular authorization. I'd probably agree with you, but I include it in my notion of isolation. And now we're going to go out and talk to some sort of compute nodes. And I've generalized compute node here. This could be EC2, this could be containers, this could be Lambda. Whatever the compute construct we have here, when we are working with those compute constructs, we need some notion of an isolation policy at this level. Like, how do we control the access of those compute nodes? How do we make sure one compute node isn't able to access something it's not supposed to? And then the same thing is true as we wander down into the storage part of this equation. Here, as we touch the storage and the different resources as we leave these compute nodes, we need policies at this layer as well that will control our access. Now, let's look at a very specific example of how to implement this sort of policy-based approach with IAM and how IAM can help us with that. And I want to be very clear that we're going to talk a lot about how IAM solves this problem, but IAM is only one piece of the puzzle. It's often that you'll need a combination of IAM and other mechanisms to get to a full isolation scheme. Still, given that we have IAM here, it's good to look at what it can do for us. So let's look at a scenario. We have this product manager service. There's a REST call that comes into it for somebody requesting some products. And they're passing in the bearer token, passing in all that context of who we are as a tenant and so on. And then that service says, I need to go get data. Now, this is a conceptual diagram. I can imagine this data access is all tucked into one service and one capability here. But that's now that we're asking for the set of products, we're essentially leaving the compute context here. We're going out to data and we're going out to access resources. And anytime we cross that boundary to go get resources, we want to say, what can we put around that experience that would potentially limit our ability to get to that resource and isolate our access to that resource? So what we're going to do here is we're going to go out and acquire some policies and acquire some context. So we're going to go out to a token manager. We're going to have that token manager go get policies from Cognito, and then we'll get a token. And don't get obsessed with the details of how it's doing this as much as conceptually. It's going to go to Cognito. It's going to get a tenant policy. It's going to get a token back from Cognito that is a scoped token that's scoped based on my tenant context. It's going to return that back to the data access manager. And then the data access manager is actually going to go out and try to get data. And now when it tries to go get data, it uses the context that came from that token that came in here. So when it goes to get that data, it will be challenged and it will be scoped to be sure that it fits all the rules we have for isolation. Now, one of the things we have to think about with using this policy-based approach is that there's a strategy where if we rely on IAM policies here, we could hit limits there. We could have too many policies, too many roles based on the number of tenants in our system. So we need some notion of how addressing that and coming up with an approach to that might let us overcome that but still rely on IAM. And so this is where we use dynamically generated policies. So here we use a token manager just like we did before. That token manager goes out to what we would call a token vending machine. This is just a concept that is sort of the idea of vending tokens on your behalf. And that will go out to a set of policies that are just policies that are the generic policies for your isolation scheme. Nothing specific to this tenant. And it will essentially bring back that template. And then it will go out to a token generator and say, I'm going to pass the context of the tenant through to you. I'm going to pass the context of this policy through to you. And then I'm going to actually go out, populate the policy with the appropriate context, and then get a policy back from that and generate a token from that, very much like we did before, and return that token from the experience. And so the idea really here is that I can sort of have these policies that are not owned by IAM. They're sort of waiting and ready as templates. I populate them, and then I use the mechanism of IAM to go generate these tokens. And now this gives me a way to sort of on the fly generate these so I don't sort of exceed the limits of IAM and its ability to manage these policies for me just based on account limits. Finally, here in this conceptual area, I definitely want to drive home the fact that as we work with tenants and as we talk to them about isolation, we've talked about pool and silo and all these different approaches. But the reality is your tenant really wants to view their resources as if they're owned by them. So whatever you do here, whatever approach you take here, you have to present to this to say, I have an isolation strategy that whether you're in pool or silo or whatever combination of those mechanisms you're using, the data will be viewed as if it's owned by you, and there will be no ability for you to cross boundaries or see another tenant's data. Now, what I want to do at this point is drill down a little more into specific AWS constructs. I want to look at compute and storage and the API entry points and look at some of the isolation themes around those. And I want to start with the API. And as I said earlier, you could debate whether the API is really a unit of isolation, but to me, it's a really strong mechanism to use in your isolation story here. So even if it isn't technically isolation, I think it's a really good thing to add onto your environment. So if you're using the API gateway and you have tenants who are calling into your environment, we could introduce a custom authorizer here, have that custom authorizer look at your data, look at your tenant context, pull that out, and then apply policies in the API gateway that would restrict your paths into the rest of the system. So here I can say, hey, you're tenant 1 and you only have this specific role. You can't access these paths. And for me, this is a great way at the outer edge to say, yes, we're going to still have isolation, but you can't even get into the resources because you don't even have the authority to get in. And this is a variant of authorization, but again, it connects nicely to your isolation scheme. Now let's look at compute. Now we've said silos so far in these broader concept of whole stack silos, but what about compute silo isolation, right? How can we take the compute constructs on AWS and have an isolated model for that? So what I've got here is some concepts that I've tried to convey that would span all of the different AWS compute models, right? So I've got a compute node here as a generalized concept, and I've got the notion of a cluster. And don't be super literal about a cluster because not every compute construct has a cluster, but conceptually I've got a collection of nodes here that are owned or are in the scope of a given tenant. And then what I'm going to do is say, for those compute nodes, I want to run them all in the context of some IAM role policy or some other IAM mechanism that would say, while they're running on behalf of this tenant, they are constrained based on this specific policy. And this is a general strategy you'll see across compute in a silo-based model where we'll say, take those nodes, and have them connected to a policy and have it so that when they come up and they come alive, they inherit that policy, and that policy then controls the entire experience for the scope of the time that they're working. And that really becomes a really strong mechanism in your sort of isolation stories, especially when you're using siloed compute constructs. So let's look at what that sort of looks like as you apply this to different AWS mechanisms. And these are probably things you're already very familiar with. They are very similar constructs that you have probably used if you've already been building on AWS. And so here on the left-hand side, you'll see I've got EC2, and I've got some notion of an instance profile. And that instance profile is essentially a part of the startup of these individual instances, and the policies attached to that profile can be my tenant policies, and then those policies will scope and control my access for everything that's done within that EC2 node. We have a similar idea over here with Lambda, but one of the things you have to sort of think about when you think about Lambda is, some people would say Lambda's already isolated because a Lambda function can only ever be running in the context of one caller at a moment in time. And you could say, that's isolation, but to me that's still not isolation because I still want to attach a policy to it to say, what can that compute node do? What can that Lambda function do while it's running? And so this is where I can attach an execution role to the Lambda, and that execution role then has the same sort of effect we had on EC2, and it will define the scope and the level of access that we have here with our Lambda functions. Now what we have to do though to achieve this here is with Lambda, we have to deploy a separate collection of Lambda functions for each tenant. And there's obviously inefficiencies of that, but it is a way to achieve your isolation story. Now, just the last sort of variant of this is EC2 cluster, a container cluster. We have ECS, we have Fargate, we have EKS. These are all different sort of container constructs, and I'm going to try to generalize them here and basically say, hey, we have a container cluster. That container cluster needs to be scoped. How can we scope it? And we have similar mechanisms available to us here to be able to attach IAM to it and to control its scope. But again, we're in a silo model, so we still have a separate cluster for every single tenant. Now, the good news of this model is this isn't just about compute isolation, right? This is about cascading the impact of that compute isolation all the way into the other resources in our system. So When I come up in the context of a given IAM role, as I reach out from that node to go touch other resources, S3 or DynamoDB or whatever sort of resource I'm touching, I can cascade those policies through and use them to scope my access to those resources to limit that tenant's ability to access those resources. And that's a really powerful construct, and it really simplifies your isolation story. As you can imagine, in pool, this is a slightly different sort of beast, right? We have more to think about here, as is the case always when we work with pool. In pool, because the tenants are sharing the compute nodes, we really can't scope the compute node down based on a policy that is a policy for an individual tenant. Instead, what we have to say is these compute nodes are going to be running on behalf of many tenants, so we have to have a way to attach a very broad policy to these nodes that isn't tenant specific and doesn't really constrain the experience for this node to an individual tenant. But that means it's pretty wide open as well. Right now, this node has the ability to access resources any way it can. And this is where our policies have to come into play to help us control access, because now the IAM policy at this level won't do quite what we want. So let's look, though, at what this plays out like, right? If we're looking at the pool model here and we're saying we need to have this broader scope and we have to look at policies, how do we achieve that with EC2 and Lambda at least? And we have this conceptual model here. We have this set of tenants that are coming in. They're running in this isolation context. And this isolation context is really a conceptual context to say, hey, when these Lambda functions are running or this EC2 functions are running, services are running, they will have to have some context they achieve at runtime, that they acquire at runtime. It won't be part of the way they're deployed and launched. And so we look at that isolation context, and we know that somewhere in the life cycle of this context, we are going to go out to Cognito. We're going to go get policies. We're going to go get, based on your identity, a policy from IAM, and that policy will come back, and that will represent our context for all the interactions here. And this doesn't have to be Cognito, it could be some other mechanism. But whatever our scoping mechanism is here to go get a set of policies here, we'd get it. And then when we get into the actual nodes and the compute constructs, now they are going to use that isolation policy to go acquire and interact with other resources. So here we'll say they run in this really broad scope, but they're going to use this context we've acquired and use that, go through some access layer and use that context to go get to the actual resources we're going to touch. And now, even though this is convention, it's not sort of baked into this, you do have a mechanism where you're assured that the context is scoped down to what's just valid for you as a tenant. Now, pool is more interesting when we get into the world of containers, right? Because containers are a slightly different compute construct. And yes, we can still do the same things we did before. We can still go get the context. We can have this context. We can still go get these policies and these tokens at runtime, and we can use that to control access to resources. But we have this real challenge here, which is to say a container still runs in a slightly different security model than other compute resources. And even with all of our efforts here to sort of protect these resources and apply isolation schemes, we can't necessarily prevent code running on that container from somehow escaping and interacting with other resources. So even though we'd like to pool here, we generally would say you really have to run an entirely separate cluster per tenant here because there aren't great multi-tenant stories to tell around this that really give you the comfort that you can achieve the level of isolation that you really need. Now, there is a variant of this that is a strategy, and obviously you can imagine in the universe of containers, certainly we're seeing new things emerging and new capabilities emerging, and I imagine this multi-tenant problem will have better answers to it as we move forward. And EKS has some capabilities here that will help us with this. We do get namespaces here, and with namespaces, some people would say, well, namespaces are your answer and your unit of isolation, but what we find is namespaces, there are caveats and nuances there where you could still cross a boundary. And so then what we do is we even bring in third-party solutions here, Tigera and other solutions that are good at controlling the network sort of dimensions of this. And let us define policies for ingress and egress and really put tighter constraints around these containers in a way that limits their ability to escape and go cross a boundary potentially to another tenant. So this is an area where if you really want to dive into EKS and you really want to go for multi-tenancy here, you just have to sort of be willing to bite off these extra pieces. And then you also should just look for the container space to continue to evolve here and offer you new options. Storage is a simpler area to talk about for isolation, and yet it has lots of complexity based on the variety of options you have here. So when we look at storage, in fact, what most SaaS organizations do is they start with storage and they say, well, if I isolate the storage, I've got isolation. And of course, we think that's too constrained. We think isolation should be the entire stack. It should cover compute and it should cover everything. But if you really look at what the story looks like inside of a storage model here, and we say we have a silo storage model, and we have this conceptual sort of notion of a database here. It could be any database technology. We certainly could have a separate database for each tenant. We could have policies, and those policies would essentially say one tenant can't cross the boundary to another tenant's database. Pretty straightforward, an extension of kind of what we've already talked about. Pool, now in pool, again, we have these shared constructs. We have shared items, shared rows in some kind of table. Could be DynamoDB, could be RDS, could be any sort of construct here. And we have policies, once again, that say, now you can only see the rows or the items that really belong to you. And the policies are going to say, hey, in this more granular fashion, you can't cross the boundary here. And these are really the foundational concepts of storage isolation. Where the dynamics get more interesting are when you start looking at, well, when we decompose our system into microservices and we really start looking at how we're going to partition data, the story gets a little more complicated. In fact, as you talk about data partitioning, you'll find that your data partitioning strategy often is very tightly interwoven with your isolation strategy. So what we'll find is, yes, with data partitioning, we'll talk about performance and scale and what's the nature of the data we want to store and what are the right sort of ways to represent data to solve this business problem. But then we'll also say, as part of that, what are the isolation needs? What do we have to do to isolate that data to meet the demands of this particular customer? And this isn't a one-size-fits-all sort of solution. You don't say, well, our customer needs siloed data, so all our microservices will have siloed data. No, we're going to say on a service-by-service basis, what is the partitioning story and what is the isolation story? So here you'll see order management here, and I've happened to choose a couple of MySQL databases. These could be instances, they could be any sort of construct, but I've basically said the performance of my system potentially, but also maybe the isolation characteristics of my system had demand that these be separate constructs. Now, when I move over to the rating side of the house, right, here the data's smaller, the footprint's smaller, the isolation story is less complex to the business. They're less worried about it getting out, and we can implement something where the performance all works. So sort of the isolation needs and the partitioning needs and the nature of the data say, oh, you know what, we can throw all this into a DynamoDB table, use a pooled model, and that fits really well for us. And then finally, I have this account one on the right-hand side. And here we've said we're going to use Dynamo again, but for the account data, our system demands that it be isolated. So we're actually going to have a separate table for each tenant. So for me, the broader story of this is, as you're considering data partitioning, consider it on a service-by-service basis and sort of overlay isolation on top of all these performance and data profile and all these other considerations that are part of your overall SaaS design. Now, I want to look at a couple examples of what it means to implement isolation. Again, there's just so many flavors of services and capabilities that we can't really look at them all, but I just wanted to give you a hint of some of the things that are possible. And here's pool-based isolation with Amazon DynamoDB. So here you'll see I've got an IAM policy, and near the end of the IAM policy, you'll see I have a condition down there. And that condition has this notion of a leading key. And here I've simplified this a little bit just to make it appear better on the screen, but I've essentially put tenant 1 in there. It'll probably be a GUID or some other value that's in there that's actually your tenant ID. And that says basically anybody running in the context of this policy can only access items in my DynamoDB table that have that leading key value of tenant 1. So if somebody is running in this context and they try to cross the boundary and get to another tenant's data, they won't be able to. So here's my table, and now it constrains my view to just those items. Really effective strategy for implementing pool in DynamoDB. Now, as just sort of to give you an entirely different dimension of this, and one that doesn't really rely on IAM policies, I'm going to look at row-level security with Aurora PostgreSQL, right? Like this row-level security doesn't use IAM. It uses its own sort of baked-in mechanism that's part of Postgres to achieve our isolation scheme. So here, in this model, we essentially initialize our table, we set it up, we tell it we want to use this row-level security mechanism, and we tell it, hey, in the context of a current user, a current tenant, here's how to scope the policy and scope the access. And once we have that initialized, now when we go to run queries and we go to invoke any kind of mechanisms that's going to acquire data, we're going to inherit those policies that were configured and set up here at the beginning. So now in this first example, you'll see a query here where we just say, go get items, all the items out of this tenant table. Because I'm scoped by tenant, it's only going to return me the items that are valid for this particular tenant. Now, at the second line just is there to sort of emphasize the point that as you go to get this data, if you tried to somehow force your way in and try to get to a different tenant ID by putting a different value in the where clause, the row level security would still prevent you from crossing that boundary. So here, again, this is sort of demonstrating the point that each technology, each partitioning scheme, each isolation scheme may have a different approach to achieving your isolation goals. And finally, I wanted to include S3 in here just because S3 is another variation. So far, we've mostly said databases and NoSQL sort of solutions. What would this look like inside of Amazon S3? Well, it turns out it doesn't look all that different than it did in Dynamo. We're going to go define some policies in IAM, and those policies are going to basically say, for this particular tenant, you can only see tag value, objects that are tagged with a specific tenant. So you'll see on the right-hand side, I have a bucket, and then those circles sort of represent the tags there for tenant 1, 2, 3. And then in the policy, I would essentially scope access based on a specific tag, and that would constrain my view just to those objects that are tagged with that tenant ID. Now, the real challenge of all this, like I've said all along the way, though, is I just went out and grabbed a handful of AWS storage services. This isn't even all of them. And imagine for each one of these storage solutions, you have to think about, well, what does it support in terms of IAM? What does it support in terms of partitioning? And how all those things will they come together and meet the performance and the sort of access use cases I have for my particular solution. And each one of them require their own approach. So you'll have to formulate a strategy on a case-by-case basis. And you'll also have to think about how will this affect IAM limits, and you'll also have to look at scenarios where you may be building your own sort of cluster. Imagine you go grab some open source technology, some storage solution, you're managing the cluster yourself, there's no IAM integration. Okay, that's great, there's no IAM integration. You can't really just say, well, we're just not going to do isolation for that one then because we manage it ourselves. No, you're still going to have to come up with your own solution and your own strategy. So where I said at the beginning that storage was pretty simple, it's true, the concepts are simple. The problem is the landscape is really wide and the set of options are really wide, and you have to get really familiar with what are the capabilities of the particular solution you want to use. Now, I've sort of hinted at the idea that IAM isn't going to be enough for you in all cases. And I'm always hesitant to say, well, okay, what's the alternative to using IAM? Because the reality is the alternative to IAM is sort of wide open landscape, right? It depends on the stack you're using, the technology you're using. You can imagine Java versus .NET versus Node.js, the mechanisms that are available to you, the open source frameworks that are available to you might all be different, and they might all have varying approaches to this problem. Still, my point is, even if you have to go build something of your own, you need some mental model for what it's supposed to do. And so I at least wanted to convey conceptually what that mental model might look like as you sort of define and pick your own approach to this. So on the right-hand side, in fact, what you'll see here, by the way, is this is very much mimicking IAM, right? I go out, I authenticate my system, and then I go out and I get these policies as part of authenticating. And as part of that mechanism, I'm somehow going to bind your identity to a specific policy. That may just be some kind of linkage. Doesn't mean I'm going to carry the whole policy around with me, but I at least have some way to connect you to the policies that apply to you in this context. These policies are defined by you and by the tool you're using, and they will describe access to the resources that you're trying to control. Now, if you look at the left-hand side of this, now I've sort of generalized this to say, okay, now I've got my own policy mechanism. I've authenticated, I've connected the identity to it. And now as I flow into one of these compute nodes, the most important concept here is to say, as I try to go access resources, something has to sit between me and the resource I'm actually trying to access. And that will be the thing that actually enforces the policy. So it's great to have the policy, but now we need something on the other half of this that will say, as you try to go get this in some non-invasive way, hopefully in a way that's sort of outside the view of the developer, something will enforce the policy and limit my ability to access the resource. So this is a generalized model. Some people use role-based access control or policy-based access control or ABAC. There's all kinds of libraries and tooling out there that are emerging around this. So I encourage you to go look at that and look in the context of your own stack at what might be a good fit. Okay, so we've sort of looked at a handful of options. We certainly didn't cover the entire landscape, but if you were to sort of step back from this and say, like, what are some of the trade-offs? What are some of the strengths and weaknesses of these approaches? Well, I think silo, the pros and cons of it are pretty straightforward. It's coarse-grained. It's really good isolation story, right? In terms of telling your customer they're isolated. It's really straightforward in terms of implementing it usually. And it has really good alignment with the AWS stack of tools, right? Networking constructs, accounts, these are all things where sort of building boundaries between tenants are already sort of naturally baked in. Of course, we get the natural cons here of a decentralized model there. Deployment gets harder. Cost optimization isn't ideal. Manageability is not great. And we have to think about account limits here. So how many VPCs can I have? How many accounts can I have? So on. Policy-based implementation is nice in that it gives us more fine-grained control, right? We get to control the access to resources, a much finer model, and it lets us take advantage of resource pooling. Now we can share resources for tenants, and we can get the economies of scale of that. And I think overall, you could say it's a little debatable, I think you get a little more flexibility out of that. Of course, in this model, you may have a harder time getting your customers to buy into this model. I think, though, you can push here, and they'll usually go along if they have confidence that you've built a robust solution. And this then relies generally on a convention from your developers. People have to comply with this model. You can do the most you can to build frameworks, tools, and libraries to take it out of their view, but to some degree, there is compliance and convention that has to happen to make all this work. And then this usually relies on a mix of technologies and approaches. And again, here you could worry about account limits, especially on the IAM side. If you've got an approach and you've got 50,000 tenants, you have to think about how those policies and roles might scale with you. The reality is you're probably going to end up with a hybrid of these things, right? For some of your solutions, you'll do silo. Parts of your stack, you might do silo. For some, you might do pool and use these policy-based approach. You're going to look across this and look across your domain and see what your customers really want and say which mix of these things are right for me and really develop your strategy in that way. Now, one of the interesting bits of this is we will have this whole discussion of isolation with organizations, and they're like, we're awesome, we built it, I'll even go there, and they'll say, yes, we've got our isolation model working, we love it. And then my question then will be, how do you know it's working? Like, well, have you proven to yourself that it's working? And that's the really challenging part of this problem, which is, yeah, it's awesome to have a really great model, but if you haven't done something to validate that it's working, that really doesn't give you the confidence that you've really covered all these isolation boundaries. And I really want to build a great sort of testing framework for this anyway, because one of the best scenarios I love to see is one where we build all these great tests for isolation. We use them for 6 months and we never had a problem. And then somebody makes a change in code and our tests actually catch that something unintentionally crossed a tenant boundary. I would much rather catch that use case in my testing environment rather than getting it out into the wild. So what might that look like? Well, there's a whole bunch of different ways you can test this, but conceptually imagine a tenant comes in, a tenant tries to come into app service, and then it wants to go get to data, the same sort of pattern we've been looking at here. And in your test, you could say, I'm going to inject a different tenant here. I'm going to say, you came in as tenant 1, but I'm actually going to go try to get that data as tenant 2. And when I try to cross that boundary to go to get tenant 2's data, if my isolation boundaries are actually working and the mechanisms are actually working, I should see that it prevents that access. That's a very simplified view, but you can imagine developing a really robust set of tests around this And I really think you shouldn't leave this off the spectrum of things you're thinking about when you're building your tenant isolation strategy. So some key takeaways here. Hopefully it's very clear that isolation is this foundational concept and one that should be baked into all your SaaS sort of architecture and thinking. And you should design every element of your system with isolation in mind, because isolation is a foundational piece to your business. Again, think always of what it would mean for somebody to a tenant to accidentally cross a tenant boundary and what the cascading impact of that could potentially be in your business. And accept the fact that isolation is going to be a huge investment of effort, but it may not, you may not ever see an event that is an isolation event, and that's just good news. But at least when or if that were to possibly happen, you've built a framework and a model for catching and preventing it. Hopefully it's also clear that authentication and authorization just aren't enough, right? Like, yes, they're great. They're a huge part of the story. We connect to them as part of our isolation scheme, but isolation is sort of an incremental piece. We add to authentication and authorization to give us a really robust solution. Account limits, we set account limits a lot through this, but a lot of people won't think about this initially. As you're building your solution, start out by thinking about how many tenants are really going to be in here, and will the strategy I've chosen based on the number of tenants I have, will that like exceed account limits on AWS? And if it is, what's my approach going to be to that? You have to build your own isolation solutions here at times too. I think I've emphasized this point, but I think we talk a lot about IAM, we talk a lot about the AWS constructs, but the reality is there may be scenarios because you're either hosting your own mechanisms or because of your unique way you're representing data, or this particular technology doesn't have the isolation scheme you want. You don't just punt there on isolation and say, I'm gonna just sort of not have isolation for that part of my system. No, you have to go out and figure out what you're gonna build on your own to close that gap. Another key point here is that each service in your system may have a different isolation model. And you should approach isolation on a service-by-service basis, not on a system-wide basis. And I think you'll find that that gives you lots of options in thinking about what you want to do, but it also gives you ability to say, hey, there's areas in the system where isolation may not be, need this super robust, super siloed sort of model, and we can get real cost efficiencies out of that, and the customers won't mind because that data is fine in that model. Well, then absolutely go down that path, because we obviously want those cost efficiencies wherever we can get them. The other thing is you have to figure out if this isolation model is actually working. Don't just rely on we're using these best practices bits. Like, even if I'm on a VPC and I've defined a security group, and I can say, well, the security group's there, so I know it's going to work. No, I'm still going to go build a test that validates that that security group is working. And then the last point here is that hopefully you just realized isolation, even though it's not very glamorous, is fundamental to any SaaS organization, right? You cannot succeed as a SaaS organization, even if you're B2C and as a consumer-facing application all the way to some large enterprise. If there's ever a scenario where tenants somehow cross a boundary you don't intend for them to cross, the impacts can be very large. So it's worth the effort and the energy to focus on this. So thank you so much for participating in this and listening to my content on tenant isolation. I hope this gives you a good general sense of the possibilities that are out there and a framework for thinking about isolation, and really gives you a sense of how important this is to your SaaS solution. Thank you so much.